What's up, guys? This is Heiss, and today we're going to talk about locomotive defects, and specifically the locomotive defects that BNSF used, at least their nomenclature for that. That's where my experience comes from, because as some of you know, I used to be a mechanical foreman working at the Interbase shop out on BNSF up in Seattle, and our primary responsibility was to do preventative maintenance, change the oil, and, be like locomotive Jiffy Lube. But it was quite often that things would come in unscheduled, as it were, due to the defects that they had on them that we had to fix to get the power back out on the road. Some engines were better than others, some were worse than others. But the point is, there's a list of all these different types of defects, and they're mostly numbered based, levels 9 through 1, 1 being really bad, 9 being not so bad. And then there's also a bunch of ones with letters, and we'll get into all that. So some of these were used all the time, and the ones that were not so common we're just gonna dip into very briefly. But I figured, hey, do you guys know how locomotives can fail? Have you thought of all these different things? Maybe you have, maybe you haven't. But let's jump right in, shall we? So we'll start with the numbered defects, and we're gonna work our way from 9 to 1. 9 being the most common and least impactful defect. A level 9 defect on the BNSF is a minor defect that needs to be fixed. It seemed most of the time that these level 9s were mislabeled because it was the default, it was the simple thing. So sometimes you had a very big problem on the locomotive that got placed on as a level 9, or a train crew member had called into the mechanical desk, and the mechanical desk didn't understand what the train crew member said, so they put it on as a level 9. Sometimes it wasn't a defect at all, and it was just information. Anything above level 9 would start to flag the unit in the computer systems, but a unit with level 9s wasn't the end of the world. The bread and butter of the level 9 defect is something that doesn't truly affect the performance of the locomotive or the safety of its crew. Something that might be a minor thing that might need to be tracked, something that isn't a big deal, something that you can take care of the next time it comes to the shop for routine maintenance. Some of the informational stuff was automated and based on samples. So every time the locomotives came in for service, you'd take an oil and a water sample and you'd ship it off to the lab to be analyzed, make sure the locomotives are good. And sometimes you'd get some of the materials from the main and connecting rod bearings in the engine, some of those little molecules popping up more in the sample. And so they would toss a level 9 on it and say, hey, next time you're looking around the engine, take a look and make sure you're not seeing powdery material or a bearing that's coming apart. Not enough so that it was like, oh my goodness, we need to take care of this right now, but a little thing to keep track of. Other things might be like the air conditioning not working when it's in the winter, or you're in a place where it's cold. Well, the air conditioner doesn't work. Does it matter right now? No. Will it matter in 6 months? Probably. That's kind of the bread and butter of level 9. But speaking of when that AC doesn't work, that's where we get into level 8. Level 8 is the locomotive operating just fine, has all its power, but you can't have a crew on it for some reason. Toilet doesn't work, engineer's seat's broken, the air conditioning doesn't work, and you're in Arizona and it's the summer. That kind of thing. So if you had a level 8, you couldn't run the locomotive in lead position. You could still use it for power as a B unit, basically, or in trail behind, but you couldn't have it for a crew. Level 8s were also pretty common and were kind of annoying for transportation to deal with, because the power would come in and they don't want to have to go down to the Y and Y the power. They'd like to just put the power on the next train and send it back the other way, and sometimes they couldn't because there was a level 8 on the one end. So it became very often that it was a request, hey, can you have somebody come out and look at the toilet? Well, you're out at the yard. What are we going to do to the toilet that's full when you're at the yard? It's got to come to the house, dude. Come on. One of those common fights that we used to get into between mechanical and transportation. Now, the next several levels were really uncommon. 7 through 4. I think I saw level 7 through 4 like once or twice. Not each, but just at all in my 3-year period. And I think part of this was that a lot of times these actually got mislabeled as level 9s. But here we are. Level 7 says that there's something wrong with a traction motor, or there's some other small operational restriction, but you're not losing any horsepower. Big 6 traction motor locomotive actually still outputs all its horsepower, 4,400 horsepower, even down onto 4 traction motors. It may not want to do it very quickly, but per the math, based on what the company said, that is the standard that they were okay with. And anyone who's really pulled freight with a C4 style locomotive that is a 6-axle but only has 4 traction motors will tell you that that is full of crap. But that is what the math says, and so that's what they ran with. But if you had one traction motor that was cut out for some reason that was bad, maybe it was grounded out or something, and it happened en route, and the locomotive needed to get to a shop, it was pretty common that, okay, you put that defect on, that traction motor's tagged out, you still run it with 5. Although it was more common that that sort of thing got tagged as a much higher level defect because people see the big cutout tag hanging on the back wall and train crews don't like it, so it wasn't too common. A level 6 was saying that there is an issue with the engine, the physical diesel engine itself, where it can't actually provide its full RPM range, up to a 25% loss in horsepower production. A level 5 is multiple traction motors cut out, 25 to 33% loss, so a little bit more, losing more power, losing more ability to pull as we go up. You can see where we're going here. A level 4 was that something in the electrical is wrong and it's losing up to 70% of its horsepower, which was very rare in happening because you almost never wanted to operate the engine if it was that broken. If something has gone that wrong that you're losing that much power, you're just beating the heck out of everything else. So the 3s, like I said, 4 through 7, not terribly common, usually labeled as a higher level defect or mislabeled as a level 9 if it was one of the lower level ones. But that's kind of what those are. Level 3, we're starting to get into the big ticket ones. Level 3 is where you can move the locomotive. It's still able to be moved, but it has to be isolated. It cannot provide any power. So that means the engine can be running, but you can't have it hooked up in MU and everything, where if, you know, it's in a consist of 6 locomotives, the lead engine revs up its throttle, that one can't. It needs to be isolated, incapable of applying any power, usually because of some electrical system problem. And the reason you tend to see these is rather than draining the engine of its coolant and everything in the winter and shipping it dead and then having to deal with it being dead batteries and out of air and all this junk when it gets to the shop to be worked on, you could keep the healthy part of the locomotive up, the diesel engine, keep that running, keep it warm, all that, not worry about spitting coolant everywhere, and you could get the locomotives to its destination. Didn't matter near as much in summer as it did in winter, because in winter, that's when you run into all the coolant problems, because our diesel locomotives didn't use true coolant. They used water that got treated with borate. That's it. It's not antifreeze. So if it gets freezing outside, the water is actually designed to dump through a special valve so that it doesn't crack the block. And if it doesn't dump, it does crack the block. So you'd rather tow the locomotive isolated, not applying power in the winter, than just towing it dead. But that's what a level 2 is. Level 2 is you have to tow it dead. And that's usually something has gone very wrong with the diesel engine. Or it was the summer and you didn't care and they didn't feel like being granular and whatever and said, no, move it dead. Or lots of other little situations that lead to that. But engine's gone wrong. Something bad has happened. The choo-choo is really broken at level 2. It was a bad time when a level 2 came into the shop because you knew you're going to have some serious troubleshooting to do. And finally we get to level 1. What's a level 1 defect? This choo-choo is so broken that it cannot be moved. Like when a level 1 happened, the eyes of Sauron, the tower in Fort Worth, the eye would swing over and it would look directly upon you when the level 1 happened. You had to respond very quickly because if you have a level 1 happen on the main, something happens, like a traction motor usually would, it's almost always the cause of level 1. That the gearboxes could lock up, and so they would slide. And so if you try to move this engine, it's just going to be grinding, breaking that wheel further, increasing the chance of derailment, and also increasing the chance you're going to break something wayside on the track. And so typically, you would have to walk the thing into the siding by greasing the rails ahead of it or something like that, or hopefully you were able to get it to a siding first, and then they applied the level 1 defect. But if you have a level 1, you're not supposed to move it, or if you do have to move it, it's very small and needs to be dealt with in field before it gets shipped back. This is things like the infamous 6324 story, which I should probably tell as the stories from the shop one of these days, where it slid a wheel flat, wheel wouldn't rotate, the pinion got locked up and everything, so the traction motor wouldn't spin. So they had to pick it up with cranes in the field, out in the yard, roll the wheel set out, put an idler wheel set in that had no motor so that it could roll, ship it to the shop, and then we would put a new traction motor that was sized appropriately back into it, rather than trying to figure out how big the wheels were in field, because they need to be within such a tolerance. And if the locomotive wasn't brand new, there's no way to guarantee you could just toss a brand new one in, and traction motors are big and heavy, and unloading from a truck in the field is a disaster. So level 1's a big deal. That was always a challenge, and it seemed like they happened maybe once every other week, or once every 3 weeks in my territory up in the Northwest. It was often enough that you kept your head on, and you hear about a level 1, it's like, okay, no matter what, somebody's got to go deal with it, no matter what time of day it is. So that was always interesting. And that's all the numbered defects. Those were the most common ones, obviously 9, 8, and then 2 and 1, really. 3s were there sometimes, and then, like I said, 4 through 7, very infrequent. But there's also a lot of other very subsystem-specific defects that they came up with that were all assigned letters of the alphabet. And again, I'll go through all of them, but we might not spend too much time on the less common ones. A level A defect means that there's a problem with the distributive power equipment. Distributive power is when you've got a set of locomotives up at the front and then one at the back or in the middle of the train somewhere, and you communicate via radio between those sets of engines. And if something was wrong with the equipment that allowed that to happen, such that it couldn't, it got a level A. So that means, okay, it doesn't work as a distributed power locomotive, but if it's paired to one that is, it'll work just fine. So, okay, so you couldn't have it be the paired mate in the set, either as the leader that was pairing back to the set at the back, or the one at the back that was receiving the signal. It could be MU'd to that one and it would work just fine, but it couldn't be the one talking. A level B was one I never saw, and it's, again, with distributed power, but it wasn't specific to the equipment of the distributed power system that was preventing the system from working. Kind of a strange one. A C. A level C was kind of a hot commodity if it happened, and it almost always actually got labeled as a level 9, that then somebody would upgrade to like a level 2 for visibility, because that's how you actually get things done on the railroad, is you just call the other guy's boss and call the other department out until somebody finally screams and the Eye of Sauron aims at them, and then you are forced to act, and then things get done. So the lettered defects weren't so common, this one didn't come up all that often, but when it did, it was a big deal, because it is a working locomotive that does not work as a remote control locomotive. We have remote control locomotives in the industry. Goodness, Seattle had like 8 assigned to Seattle all across different areas. And they're a different class of service because a single conductor who's trained on RCL can operate it from his basically belt pack Xbox controller and operate the locomotive by himself. And so the railroad loved it because one-man crew, baby. We ain't got to pay 2 people. We got one guy that can do it. Which is a whole nother topic, of course. The remote control jobs are bid in such a way, and they only have so much crew in such a way, that if you're having to call an engineer and conductor to do that job rather than the RCL conductor, you're removing your pool of people that can go do the other jobs around the terminal, and they were trying to run it bare bones, because that's how you save the most money. Welcome to the railroad. And so if the RCL equipment wasn't working, you heard about it. It was a big deal. So the RCLs would come over, and yeah, it was almost always with a higher level defect. I never saw a level D. And a level D is described as having full horsepower, but it has the potential to lose horsepower. Something is kind of wrong with it. Like there might be a problem. We're not sure. We might have had one of those once. We might have actually put a level D on a locomotive that left my shop once, which is a whole nother thing. That's a whole nother story. More stories from the shop. See, I start talking about this stuff, and that's what brings up the stories. People always ask, like, hey, tell a funny story from BNSF you haven't told before, and I go, when you prompt me with stories, I don't think of them, but when I get the prompt of, oh wait, a level DD, oh yeah, that's right, that did happen once. A level E, next one. This was actually relatively common, and was a big one to fix, and that means that the dynamic brakes don't work. That means you're stuck using air, or that locomotive in the consist couldn't have its dynamic brakes working, which reduces the braking effort. And these days, a lot of engineers really use a lot of dynamic braking and not a lot of air in a lot of situations. This might be the biggest, most obnoxious one to deal with of them all, the level I. And that means that the locomotive is past due for an FRA required maintenance. Happened all the time because the yard would use the power right up until the drop dead date when, okay, it's due for maintenance. And then it would sit. And so you'd have this locomotive with a level I saying, hey, it's past due for FRA. Like, it needs to be maintained. We have to go through and certify things to guarantee its safety. And if we do not do that and we continue to operate the locomotive, the engineers and conductors themselves could get fined directly, not the company. The individuals could get fined if they use it. And it's like, the locomotive's been sitting out in the yard for 7 days, they won't bring it over to the shop. I've Sauron comes to you for that one. Why hasn't that made it to the shop yet? What do you mean? It's past due. It needs to go for maintenance. Why hasn't it gone to go for maintenance? It's very simple. Get it back out on the road. Well, one of the reasons Interbase shutting down is because it was very hard to get power to, because we were on the other side of the main from all the yards. So we had 2 or maybe even 3 main lines in some spots through Seattle there. And you wouldn't want to interrupt the traffic going on those mains, especially during the window for commuter train service. And so, of course, when they're building power and they have time to move stuff is when they're not having all those issues. And so they want to focus on their goals as transportation, building trains. So they didn't want to bring the power over then. And then when they could bring the power over, then, oh, the sounder's going by, and, oh, we can't come over because the sounder's there. And then the power would sit for 3, 4, 5 days. And then they'd bring us 12 locomotives at once, and we'd run around with our heads cut off, dealing with 12 locomotives that all need the same maintenance that takes 8 hours apiece to do, wondering where they were all week. Yeah, that's the railroad for you. Just a symphony of well-planned beauty, for sure. A level K. These got really, really common, and the Best Way team tended to put these out. The railroad developed a team of people, which I think they have actually since scaled back, because it turns out trying to be better at things costs money, and the railroad may not like that. A level K was saying that the automatic engine start-stop system doesn't work. The locomotives got either modified or built brand new with a system that would monitor how the diesel engine's doing, how much air they have, how charged the batteries are, and all that. And if everything was happy, they would shut down the engine automatically to save fuel. And then if one of those parameters fell out, you ran out of battery charge, you ran out of air, or not ran out, but got too low, or the engine got too cold, would fire back up and then run until it met those parameters again, then it would shut down. So level K says, hey, this system's not working, the engine's just stuck running, we're wasting fuel. Because you realize, okay, well, it's a big diesel engine. It's talking like liters upon liters. I mean, the EMD power, the big stuff, has a 710 cubic inch cylinder and 16 of them. So at idle, they burn a couple gallons of diesel in a day, which, okay, a couple gallons in a day for that big of an engine doesn't sound like much. And then you multiply by like 8,000 locomotives across the system, and then, oh, that becomes a big number in terms of dollars, of course, later on. So they were looking for ways to minimize level Ks and make sure that we were saving money on fuel. A level L, I don't think I ever saw either, and it was a specific code for engine or air compressor oil, those samples that they took. Something was wrong in the sample, and so they put the level L on it, and I think they usually ended up as mislabeled again. A level P. Ah yes, PTC could have prevented this. No, PTC caused this. Level P says that PTC's broken, but the choo-choo's fine otherwise. So you couldn't use it in lead in these days now, of course. But as we were implementing PTC, they ended up getting used because we weren't truly required for the longest time. Although BNSF actually did do a really good job at trying to be ahead of the curve on all the PTC things. So they actually ran full PTC before it was required. So that's an actually admirable thing that they did. But yeah, PTC's quite the complex system, and it had a lot of teething issues to get where it is now. And even now, it's still not the perfect system, and they're always rolling out new software patches as we find more weird things down the rabbit hole of possible failures. So they're finding all those little things and changing things. But sometimes you'd have something break on the engine, didn't have a part, or it was out in the middle somewhere, and okay, put a level P on it, trail it to a shop, take care of it. That was pretty common. A level R I might have seen once or twice, and that means the event recorder wasn't working, which is also a level 8. It means that you can't record what happens in the locomotive. So when the throttle was changed, when the brakes were changed, and for the legal lawyer side of things, that's a big no-no. And the FRA has pretty strict ruling about event recorders, so if that didn't work, it was in trail, basically. Level S we did tend to see, but that's because we had old junk power that came to Interbay all the time. Level S means that it's excessively smoky, which, well, old two-stroke EMD diesel engine, maybe it ran for too long, maybe the AESS was broken and it was sitting, souped up, dumps white smoke. Yep, they got a level. Those were pretty common. We'd come to the shop and we'd take care of them, and that was that. A level T, it was a weird one that I don't think I ever saw. It was more applicable to the bigger engines that had like computer-controlled air brakes and stuff, where certain specific pieces had separate due dates to be done, and it means that one or more of the components are past due for their maintenance. So that was kind of a more granular thing for locomotives that had more advanced systems than the slobber bucket junk that we had. And the last but not least, and actually probably more common than most of these other lettered defects, other than maybe the level I, is the level W. Unit flagged for a wild wheel alarm. Wild wheel! What does that mean? They have pressure sensors in the track, and that feels how heavy each wheel set is and all that stuff. And if you have flat spots, that wheel's gonna be slamming the track pretty bad. So flat spots, shell spots, any wheel condition that makes a wheel look scary like this tends to pound the track pretty hard. So much so that you'd get ratings like 100 kilopounds, so 100,000 pounds of force on the rail at that sensor. These locomotives only weigh like 400 to 450,000 pounds total, and they have 12 wheels usually. So if you're getting a quarter of the weight of the locomotive slamming on one wheel, you know something's wrong. So level W would come up and it would be, okay, get that thing to the shop right now. Next shop it can see, send it in. There's obviously something wrong with a wheel or a bearing or something, and it was almost always a wheel. And it would go for wheel true or new wheels or whatever it is, and that was a pretty common one. Anyways, guys, I hope you liked to look at defects on the railroad and many of the ways that locomotives could have things go wrong. The unscheduled things that stops the trains. Yeah, it was always interesting to have these come around, and remember, those are specific just to BNSF. I'm sure that other railroads have similar codes and have similar granularity for these things, because we all interface and experience the same problems with locomotives, but that's a little bit of a look at what all of that looks like, and some of the fun joys of being in the mechanical shop. Anyways, guys, thanks so much for watching. We'll catch y'all next time.